Now that we have some intuition, hopefully, of what complex numbers are, we're going to try and figure out the powers of I. Powers of I. And in the last video, we defined I to be equal to the square root of -1. And we're going to use this definition as well as our exponent properties to figure out all the other powers of I. So you might want to go and review your exponents if you think you're not quite up to code in them. So let's just start with I to the power 0. Well, because anything to the power 0 is just a 1, I to the power 0 is also going to be 1. Actually, let me color code this. Let's now talk about I to the power 1, which is just going to be I itself, because anything to the power raised to the power 1 is just itself. Now let's go to I to the power 2, or I squared. Well, by definition, we know that I is equal to the square root of -1. So if I take the square, if I square both sides of this equation, I'm going to get I squared equals a -1. There you have it. Now we're going to try and figure out I cube. Well, I can write I cube as the product of I square and I. I simply used my exponent rules. So if you add a 2 and a 1, you get a 3, so I did nothing wrong here. But what this does is, it helps me calculate this out, because I know what I squared is. I squared is a -1, so I'm going to write this as a -1 times, well, I to the 1 is just I. So I to the third power is going to be a -I. In a similar way, I can write I to the fourth power as the product of I square and I squared. And well, I squared is a -1, so it's going to be a -1 multiplied by a -1, which is just going to be a +1. Let's move on to I to the power 5. Now there's a couple of ways in which I can write this out. I can write it as the product of I square and I cube. I can write it as the product of I4 and I raised to the power 4 and I. So which one do I choose? Well, I'm going to look at all of these here, and the least hairy of them is I to the power 5, I to the power 4. So I'm going to write I to the power 5 as the product of I to the power 4 and I to the power 1. And what is that going to be? Well, since I to the 4 is just a 1, I to the 5 will be the same thing as I to the power 1. And this is interesting. And at this point, you might be getting the sense of what we're doing here, so you might want to calculate the next few powers yourself. So I to the power 6, in exactly the same way as I to the power 5, I can write this as I to the power 4 multiplied by I square. And there's no question that I to the power 6 is going to be the same thing as I squared, because the I4 will just disappear, as it's only a 1. So it's going to be 1 times I square, which is -1. So I to the power 6 is a -1. Let's move on to I to the 7th can be written as the product of I to the 3rd times I to the 4th. And I to the 4th is just going to be a 1. And so it's quite evident that I to the 7th is the same as I to the 3rd, which is a -I, as seen from here. And now I to the 8th power, that's going to be equal to I to the 4th times I to the 4th. And that's just going to be equal to I to the 4th, which is going to be a 1, because both of them are equal to 1, so 1 times 1 equals 1. And this is really interesting, because there seems to be a pattern here. When you start from I to the power 1, you first get an I, then a -1, then a -I, then a 1, then you again get an I, a -1, a -I, here, and then a 1. And this pattern will keep on going on and on forever. So, and a key thing to note here is that whenever you have a power of 4, a power that is a multiple of 4, for instance, let's say I to the 100th power, the answer is always going to be 1, because I to the 4th is a 1, and 1 raised to the power anything is equal to 1. This is just exponent properties, right? Because first we could write I to the 100th as I to the 4th raised to the 25th power, so the powers can just multiply, and that's why it's always going to be equal to 1. So what if now I had to calculate something a little harder? For instance, I to the 37th. So to calculate this, we have to write it as the product of I raised to the power, the greatest multiple of 4 that is less than 37, which is going to be 36 in this case. 9 times 4 equals 36, times I to the first power, because that's what's left. 37 minus 36 equals 1. This is just exponent properties. And because we know what I to the 36th power is, that's just going to be a 1, because 36 is a multiple of 4. So it's going to be 1 times I, which is just going to be I. That's simple. It's not simple. Let's now figure out something like 1000, I raised to the power 1097. Once again, we need to find the greatest multiple of 4 less than 1097. And to do that, in case you don't just remember it, you can always divide 1097, or whatever number you have, by 4. And, well, let's see. 4 goes 2 times into 8. Okay, and then we have a remainder of 2, then 28, and then we get a 7. 4 times 7 is a 28. Then you get a remainder of 1, and 17. 4 times 4 is 16, and you get a remainder of 1. So you get 4, 7, 6 here. And so what you're going to do is you're going to write it as the product of I raised to power whatever remainder you get, 1, and then you're going to subtract this number in the power from the remainder to get to your multiple of 4. So 1097 minus a 1 is 1096, and this number has to be a multiple of 4, and so this power is going to be a 1, and so it turns out this number is also I. And that's how you can figure out any power of I.